Today we're diving into the fascinating world of epidemiology. We're talking about the real-life disease detectives. So, imagine this. A silent killer is moving through a city. People are getting sick and nobody knows why. Panic is starting to spread even faster than the disease itself. How do you possibly stop it?
Well, you call in an epidemiologist. See, they're not looking for a culprit with a motive. They're looking for patterns in the chaos. To really understand how they do what they do, we actually have to go back in time and meet the guy who basically wrote the playbook for this entire field. This is the story of Dr. John Snow. It's 1854 in London, and a vicious cholera outbreak is tearing through the city. Now, the common theory back then was that it was caused by bad air. But Snow, he was skeptical. So he did something that was absolutely revolutionary for its time. He started mapping the deaths. And when he put all the dots on the map, a clear pattern emerged. Almost all the cases were clustered around one single public water pump on Broad Street. Snow went to the local officials, convinced them to take the handle off the pump, and, just like that, the outbreak stopped. This one simple act of data mapping was basically the birth of modern epidemiology.
And here's the thing. This wasn't just a lucky guess. Snow was a data scientist before that was even a job title. He actually compared the death rates in different parts of London that were served by two different water companies. One company was pulling its water from a contaminated part of the River Thames, and the other got it from a much cleaner source. The data was just undeniable. The death rate in the area with the dirty water was 5 times higher. He'd used a control group to prove his case. Incredible.
So, John Snow really laid the groundwork. Now, let's fast forward to today and take a look at the sophisticated toolkit that modern disease detectives have at their disposal.
So, what exactly is epidemiology, officially? Well, put simply, it's the study of how, where, and why diseases pop up in a population. It asks the big questions. Who is getting sick? When and where are they getting sick? And the most important one, why? The answers to those questions are the absolute cornerstone of public health. They shape everything from huge national policies right down to the advice your own doctor gives you.
Okay, so to solve a health mystery, first, you've got to measure it. And detectives use 2 really key numbers for this. Let's say you're tracking a flu outbreak. Incidence tells you the number of new flu cases popping up each week. That gives you the speed of the outbreak. Then there's prevalence. That's the total number of people who have the flu right now, new cases and old ones. That's a snapshot of the overall size of the problem. So one measures speed and the other measures size. Both are crucial. All right, so you know the scale of the problem, but how do you find the culprit? Let's get into the investigative strategies that epidemiologists use to track down potential causes.
The 2 main weapons in their arsenal are cohort studies and case control studies. The easiest way to think about it is this. A cohort study looks forward in time. It asks, what will happen? A case control study looks backward. It asks, what already happened? Let's dig into a cohort study. Think of it as a really, really long stakeout. You find a big group of healthy people, your cohort, and you just follow them over time. You know, a famous example is following a group of smokers and a group of non-smokers for decades to see which group is more likely to develop lung cancer. The evidence you get is incredibly powerful, but you can see the downside, right? It can take years, even a lifetime, to get your answers. Now, a case control study is way faster. It's perfect for something urgent, like a food poisoning outbreak. You start at the end. You find a group of people who are already sick. Those are your cases. Then you find a similar group of healthy people, your controls. And then you look backwards and ask, okay, what did you guys do differently? With food poisoning, you'd ask everyone what they ate, and you're looking for that one dish that only the sick people had in common. So finding a suspect, finding a link between something, that's one thing. But proving that it's the actual cause, that's a whole different challenge. And this is where the detective work gets really, really rigorous.
And here's a crucial point to remember. In public health, there's almost never a single smoking gun. That old idea of one cause leads to one effect is just, well, it's usually wrong. Most diseases we face today, from heart disease to cancer, aren't caused by one single thing. They're caused by a super complex interaction of a whole bunch of different factors. This idea is called the web of causation. Just take a heart attack, for example. It's not just caused by cholesterol. It's this whole web, right? Lifestyle choices like your diet and whether you smoke, those interact with things like stress, which can lead to high blood pressure. And all of that interacts with a person's genetics and other biological factors.
It's a messy, complicated web, and the detective's job is to untangle it piece by piece.
So, how do they build a rock-solid case for causation? Well, they use a kind of checklist. They ask a series of questions. First, how strong is the connection? Is it a weak link or a really powerful one? Second, is it consistent? Are other scientists in other studies finding the same thing? Then, and this is critical, temporality. Did the supposed cause happen before the disease? You'd be surprised how often that gets missed. Then, is there a biological gradient? Meaning, does a higher exposure lead to a higher risk? And finally, is it plausible? Like, does it actually make biological sense? The more yes answers they get, the stronger their case.
So you might be wondering, does all this detective work actually pay off? Does it make a real difference in the world? The answer is a resounding yes. Let's look at some of epidemiology's greatest hits.
1980. This year marks one of the single greatest achievements in all of human history. Because of a massive global campaign of surveillance and vaccination, all guided by these epidemiological principles, smallpox was completely eradicated, wiped off the face of the earth. A disease that killed hundreds of millions of people throughout history was just defeated.
And the list of victories goes on. Epidemiologists trace the horrific Minamata disease in Japan back to industrial mercury poisoning. They're the ones who built the ironclad case that linked smoking to lung cancer, which became the foundation for tobacco control policies all over the world. And their work continues to fight diseases of poverty, like rheumatic fever, and nutritional problems like iodine deficiency. Every single one of these breakthroughs represents millions and millions of lives saved. So there you have it. You've seen how the disease detectives work. From drawing dots on a map in old London to untangling the incredibly complex web of causation for today's chronic diseases. The tools have gotten way more advanced, but the mission has always been the same. Figure out what's making people sick and stop it. Which leaves us with one final thought. What's the next great health mystery they need to solve?